Okay, in this lesson we're going to be talking about computing integrals. And oftentimes the hardest part about computing integrals is setting up the integral itself into a form that we can actually compute it easily. And in further lessons we are going to learn all sorts of crazy techniques for setting up integrals, but for right now we're just going to keep it pretty simple, and we're going to go over the basics to set up a series of steps, almost like an algorithm, that we can use to solve these types of problems fairly quickly. So, what you'll get is a problem that looks something like this. So we'll have an integral from 1 to 3 of, say, x squared plus 3 dx. Now, there's two important regions that we're going to be paying attention to in this problem. First one are the bounds, and that's 1 and 3, and we're going to label them like so, A and B. Now, the next area we're going to pay attention to naturally is this function here, x squared plus 3. So, now that we have these two areas pointed out to us, the first step is to recall the fundamental theorem of calculus. Now, if you remember, the fundamental theorem of calculus tells us that as long as the integral is continuous from a to b, that is equal to its antiderivative at b minus its antiderivative at a. So we can write this as so. Now, logically, the next step would be to find the antiderivative. And hopefully you remember from previous lessons how to find the antiderivative. This example here isn't really too tough. So we know that the antiderivative of x squared plus 3 is x to the third over 3 plus 3x. So now that we have the antiderivative, what can we do with it? Well, we want to basically write out this right here. Now we have a special notation, and we will make that step 3. Write integral to compute. So basically we can write this like so. We use these little boxes and we write x to the third over 3 plus 3x. Make a bar here and we place the bounds in the same location. So 3 goes on top, 1 on the bottom. Now this notation right here pretty much equals this. So we'll draw an arrow just like that. Now we can say that 3 to the third over 3 plus 3x plus 3 times 3 minus 1 to the third over 3 plus 3 times 1. Now from this point it's just simple algebra, so we'll just go ahead and do that real quick. We'll multiply all this out, so we get 27 over 3 plus 9 minus 1/3. Don't forget to keep the boxes for now. 1/3 plus 3. And we'll simplify this up real quick, and this equals 18 minus 3 and 1/3. And subtracting these out, we get 14 and 2/3. So now we can simply write integral from 1 to 3 of x squared plus 3 dx equals 14 and 2/3. And really that's pretty much it. This is a pretty basic example, but hopefully you got a good idea of the steps required to compute integrals, and in further lessons we will tackle more complex integrals and look at how we can solve integrals that require us to find antiderivatives that we're not totally sure how to find. Alright, that's it. Thanks.